time, like
Huh?
0.
Hello.
How many people are watching? Hello, we're back again. I guess you can see my screen.
Not yet.
Woohoo! Okay.
So we're continuing what we did yesterday, which was Conway's Game of Life, right?
Yes, and we were using TCR, test-and-commit-or-revert, which I think means if I change this and try and run the tests will fail, and then that code will be reverted. There you go.
And also we had the constraint that we don't create classes except type classes.
Yeah. I mean, that was an experiment. I think that maybe a thing well, so today I wanted to do 2 things. Well, I think maybe we wanted to do things. One was better visualization to actually see what a board looks like, and maybe even run a board, because at the moment we've got this idea of just stepping a board from one state to another, but it would be good to have some way of sort of running it forward in time, but in particular to be able to see it as it happened, because at the moment all we can say things like actually these are all a bit rubbish, aren't they? Because didn't we have a thing of a blinker? Or maybe not. We decided these were a blinker, but yeah. So at the moment we don't have a single thing that shows what a whole board looks like, do we? So we've got no visualization.
What do we even have if you scroll up?
Like
test count neighbors. Yeah, we can do that.
Yeah.
On a board.
Rules about yeah, well, these are the rules, I guess. 1, 2, 3,
1, 2, 3, 4.
Oh, and there.
I guess what's missing, the dead cell with 2 neighbors doesn't come to life. I think that's kind of maybe missing.
Yeah. Shall we edit?
I suppose so, yeah. I just realized that was kind of missing.
And I've also realized that we're not actually sharing this controller's computer at all, are we? Let me
if you call me.
Bring you into tuple. There we go.
Oh, nice.
Okay, so a dead cell with. Oh, you're typing. Excellent. Right, go.
You go
ahead. Dead cell with 2 neighbors does.
Yeah, sounds good.
So, yeah, you're really good at visualizing these boards, and I'm just not. Or we can do this. We can do this after we pass the board, and then I can visualize it.
Just do with this one. That should still work, I think. But okay. Oops, sorry. Maybe it wasn't right.
Tell you what, let's write some code to visualize boards, and that way it'll be a lot easier to write more of this stuff, right?
Yeah, I agree.
So I kind of hate all this scrolling up and down, but I'm going to carry on doing it. Let's give ourselves a test, and let's we visualize the board first and then parse it. Parse 1 after we've done that. So empty board displays as empty list. I'm just sort of roughing out what. So what I'm thinking is something like, if we start with an empty board, then list of strings are quite easy to deal with, because if you just deal with the string, you end up having to like parse the line endings out of it or do here documents. Whereas that board.sequence well, toString won't work because we can't add a toString as an extension method, because the actual toString method will be taken. So as string, or I kind of like printed.
Yeah, sounds good.
Although that's sort of so that's our thing, right?
It's going to be a list of strings though, so it's one string as a row. Right?
Yes, that's my plan. Just because that way it's really easy to work with the tests, and if you want to print them out on the console,
yeah, there is always a question, I guess, of what part of the board we print in, because we have an infinite one, right?
Yes, let's hold that thought. Actually, printed as I think of it is a rubbish. Let's say to list of strings, because that's exactly what we want, right?
Okay. I think it's just early stages, so I'm happy with any name. You can rename it.
Okay, do you want to go and make that work?
Okay. That's once again not what we want. We want a board. And that should go away.
Yeah.
And we want to return empty list. Okay. That should work, right? I'm not gonna go optimize this. Okay, good luck. Yay.
Okay.
So
a board with one cell should be a list of that string with one star in it, say.
So board with one cell. One cell.
I think maybe we'll just let's not bother to say what it does. We'll just do a thing.
Yeah. So if we have a board with,
but that's a board with one cell at 0, 0. So let's make it
something like that.
Yeah. That way we can punt what we do around how big the board is for now.
And then what we want here is just a list of what's the symbol? O?
I like stars and dots, but that's just me.
Oh, what? Can you type it? Okay.
Yeah, whatever. Yeah. I mean, we could always pass it as a parameter to list of strings.
No, I'm happy with the star. Looks like a cell thing.
Okay, so
you're gonna cheat, right?
So I don't see it as cheating at this point, and I think you may see why later. So I'm going to say if is empty list, but I am going to cheat here, and I'm going to say list of star.
Okay.
Right.
Yeah. No, it's okay.
And we think that will work. I mean, I'm just kicking the can down the road a bit, but I like sort of this formulation of what's that special case that we're going to screw up later if we're not careful. And then I think this is
okay.
This is this feels to me nice this way, right? So yeah, it begins to read like Haskell, you know.
Yeah.
I like the sort of top level guard things of this thing is defined, and it's defined when it's empty as this and something else as this. So how about then if we go and so we've got a choice. We can put two cells in a line, and that would make our lives easy to start with. But let's put an empty cell in as well, right? So board with 2 cells in a row. I think lots of these will go away, right? Because we only really need one test case. Well, maybe 2 test cases when we're done, but we're working our way there. So if we said we had 0, 0, and we had 2, row column, right? 0, 2. Yeah. Then I would say that should be that dot that. And I can put the stars in just because it makes our life a little bit easier to see.
Yeah.
If I could find a character that was a dot in the middle of a thing, I'd use
Oh
that.
yeah, I was thinking about that.
Okay. I now have to force myself not to run the test and show that it fails.
Okay, should I try and implement that?
Yeah, have a go.
Well, I have no idea which way it's going to go. So we have a board which is a set of cells. Well, this is the point where I'm thinking now about the ranges.
Yeah.
And things like that. So I'm tempted to do something dumb like that. And that's going to be our range. And then we map it based on if the cell, so we'll create some cells. It will be, what do you say, column row? Oh, it's a row column. So that's going to be a row. And our cell is actually a pair. So it's
Why don't we leave why don't we just do the column, right? Because in this case we've only got one column. Let's do half of it and get it working.
Yeah, that's what I meant to do. Sorry.
Ah, right. In that case, that's column.
I was a bit confused by the thing, so it's the other way around. Thank you. That's a cell. And then we want to check if this cell is in the board, which is this. And if it is in this, then it's a star, otherwise it's a dot.
Yeah.
So if this is the case, that's else it's a dot. And that's probably, no. Oh, that's joined to string, right?
Yeah, joined to string.
And that's a list of that. Well, I feel like I wrote lots of stuff. No idea what's going to happen now. Should I run it?
Yeah, go on. Because, yeah, I mean, it says it compiles. Not the way I'd have written it, but I'm interested.
Oh,
okay.
no, then.
So we get rid of that. We get rid of that rubbish.
Oh, I see. I can see what was wrong. I didn't join it. I joined it with a comma by default. That's why.
Right. Yeah. Sorry. I was confused by the list early. Can I try and reproduce what you just did?
Yeah.
So.
Sounds like a good practice instead of me typing things again.
Yeah. So I think you said so. You said 0 to 2. How big is the board? Is that so? I never know whether this is inclusive or exclusive.
It is inclusive in Kotlin, just to make things more interesting.
So that includes 2.
Yes.
And we've got a 2. Okay. So that seems
well, we
right.
don't have 2. The test is gone now. Right.
Oh, God. Damn it. Right. Okay. Let's back this out. This time we will do a thing that doesn't result in that losing that test. I've got to say, I think your mode of not reverting tests is the same one for TCR, but as we're doing everything in the test file, it doesn't work, does it?
Yeah.
Okay, so this is board with 2 cells in a row. That's board of 0, 0, and then 0, 2, 2. Right? And I'm going to say, let's not run this yet. Is that cheating?
No. I think it's okay. We also need to update assertion, though, right, on line 62.
Yes.
Or don't change assertion and just run it, and then it will commit it. That's another weird thing to write the wrong test.
Yeah.
Another suggestion was to rewrite assert equals to assert not equals and run it, because we expect it to fail, and that's what you encode in your assertion instead of disabling the test.
Gotcha. I can't cope with that personally.
Yeah, fair enough. Maybe if there are good tools, like you just alt enter on assert equals, it inverts it. Anyway, yeah.
So your theory was something like, this is 0 to 2 map. So this is my column. I'm going to say, is there this contains, I know you thought this was the other way around.
Yeah.
So this contains So this is the pair of my row, which is currently 0, to my column.
Yes.
Yeah.
Yes.
And we're going to ask the question. I'm going to drop that down. If this contains that, then it is a star. Else it's a dot.
Yeah.
And then that type checks.
Yes. Because we expect a list of strings, but actually we want just a list of one string. So this whole thing.
So this will be a list of star dot star as opposed to a list of star dot star.
Yes. Exactly.
That was clear. So this is join to string with a nothing.
And it's a list of, that's our first row, so we need to wrap this into list of.
Okay, yes, so that's list of. So there's going to be a thing around this that is
a
little bit horrible, and then IntelliJ is going something weird happened there on another screen. Don't worry about that. Right. So that says we can do that, which is what you were doing. That's exactly the code you had written, except for that bit, right?
Yeah.
And maybe that bit, I can't remember. Right. So we think that will pass this one in any case. So worth a go.
Oh God.
Damn it.
Oh.
Okay. Well, we're software gods, Dimitri. But we're not doing very well.
Can we write the simplest function? Are we allowed to look at what went wrong?
Oh yeah, I suppose so. I don't remember how. How do I bring up?
I'll do it. So that's what went wrong.
What? Oh, so it was the. It was the one cell case failed. Wait, what does this say over here? This is board with one cell.
Yeah.
Oh, so it was the board with one cell that failed.
Of course. Yes, that's what failed.
Why did that fail?
Well, because we always iterate from 0 to 2. Right?
Oh, good grief! Right. Okay. In which case, so the test is. I guess we hadn't enabled the test either, had we? So we know that we know there's the only one fail because we hadn't been brave enough to do both. Right. I'm going to go for this. I'm going to say that our val max right is.
I was thinking about like a range of things then, because it will be a range, right? It will be like column range, row range, which we can infer from the data or can accept as maybe parameters to the function.
So I would like to experiment with allowing the board to grow.
Oh, yeah, please.
But whether I want the board to grow, let my kind of gut feel is to say let's do it between 0 and max col, and if things shuffle off to the left, we'll leave them. Well, they'll go. That'll be fine.
Okay.
And if things shuffle off to the right, we'll just get bigger. Because if we do both, then we have this nasty effect that we'll just like follow things around the screen. We'll never know where 0 is.
Yeah.
Does that make sense? So what are we doing? We're saying this got max by
of probably. We want of, which is kind of new function, which will find the largest element and return the thing that we have. I can do it if you want. I'm pretty sure it's max of, because what we want is we want a column, right? And here we will have a cell which is row and column, and we want maximum column.
Okay, is there a max of? I never knew that.
Should we ignore this bit? That's like a new function. We can run this just to save I'll run it. Yep. And that's a way to press save button
Yes.
In reality, it would be okay to deploy to production as well.
Yeah.
Just some extra code which does nothing. Yeah, sorry. What you were doing?
Okay, so now our range is 0 to max call.
Oh, right.
Is it though, or is it 0 up to max call? No, it is a max call because that's the number we've just sucked out of there. So we know that we're going to find that thing. It's not like array indexing at this point. It's actually just matches, isn't it? Yeah. Right. So this is. Let's see if we can remember. This was join to string. With nothing.
Join to string, but that's join to something else.
String. Yeah. And then this was call. And each column we were saying this contains 0 to call. And if that's true, if this contains that,
yeah,
star else. Oh,
yeah, and that's a list of. Oh, I wouldn't delete this. Can you? Oh, do you mind if we put it?
Yeah, I thought you mean yes, yes. So run that.
You know
yes. I mean cheeky, but yeah.
Well, I mean, this is not against the rules, I suppose. So no. Incremental. Yes.
No, it feels a bit like in the old days when you were working in Word and you couldn't trust it not to crash, so you had to press save yourself all the time, and you had to manage that safety. But right, list of.
Yeah.
Okay, so this time, should we see if that feels okay?
Yeah.
If not, we haven't lost a lot, right? Phew.
Yeah.
Okay. And now, do we trust board with 2 cells in a row?
Yeah.
Oh,
nice.
Yeah, right. And then
max row. Yes, I think it wasn't just a fail, it was also a lesson. Like the reverting business. Row.
Thank you. So max of row and column to row. I don't understand what
we can try and pull the same trick because right now our max row is always 0. We can write one more loop around our code and then write a test.
So what are you saying? You're saying this is 0
to max row.
Max row. Not
just map, I think.
Each one of those will give us a string. Okay. That feels like it. So we think the max row will always be
0.
In that case, won't we get no iterations here?
Oh, no, we will have 1 because it's inclusive. So it's exactly 0.
Okay.
So it's equivalent. We'll see. Oh, I know what we missed as well. We should have used 0 in contains. Well, that's another thing to do now, maybe. Plug this in.
Yeah.
Very incremental. Oh.
That's up there, yeah.
So, yeah, in a way, I like these tiny steps now.
Yeah.
Micro.
I mean, they're just different tiny steps than you might take if you were TDD.
Then are we brave enough to say there is a column?
Yeah.
That's what you were aiming for.
Yeah.
Should we do the opposite then? And that should be something else. What is that? A second. That's a list of
Yeah, so you want a list of star, comma, dot, comma, star, I think. No, but not there.
Yeah. Yeah. No,
No.
I'm running
What?
it. Sorry. Too
Okay.
late. Okay. What was wrong? I'll type it again. Oh no, no.
Now go on.
I'll type it again. So it was a column. It wasn't much code.
Yeah.
And these were the other way around. So what did I miss?
So right, step away.
Right, of course, it's a list of strings. Yeah. What was I thinking? Brain melting.
And then let's actually lay that out, shall we?
Yeah.
Another point. Okay. Just let's check this. So at the moment, though, we're just mapping this into that, but that's okay because we don't want to join them. That feels like it should be okay, doesn't it?
Yeah.
Should I run it? Oh, yeah. Well, that's quite pleasing. And now it feels like, I mean, all of these can kind of be sort of empty board and everything else is a bit. So shall we just go to something like, let's make sure we got the right. So part of the problem here is we've been working with, if we work with square things, we never know we've got things right. So my gut says if we go 0 to 0 and 2 to 3, okay? We don't need any of these others to get this right. We just need to say, what does this look like, right? So we've got, so it's row, column. So this would be 2 by 3. So I came from TV, right? And so 3 by 4 always works for me. So row 3, column 4, we'll make a thing that's 3 by 4, which is like a TV screen, old-fashioned TV screen. So this should be 4 across, right?
Yeah.
And 3 deep.
Oh wait, we're going to 4. It's going to be like 5, right? Because we start from 0 and then we have 4, so that's going to be 5.
Ah, so you say that in fact, in order to make that, yes, that should be 2 to 3.
Yeah.
So this is 0, 1, 2, and that's 0, 1, 2, 3. Plausible?
Yeah. I'm not too sure, but looks okay.
Yeah. So armed with that, we don't care about these really, do we? I mean, if we were really fastidious, we might leave them alone. But I think empty board is an empty list. The only other thing I'm interested in, I suppose, is so this is board with 2 corners, should we say?
True.
I think there's another case that's worth documenting, even if we just believe we know how it's going to work, which is board with. Well, that's interesting as well, but I don't think that's not going to work.
Yeah.
What I think, though, this one corner, that if we do a board of that,
I see.
we want to show that we're starting at 0.
Right. Okay. Yeah.
So that's,
well,
that's documenting our sort of de facto behavior. Just so we remember.
Okay.
Okay. Now, can we parse something that looks like that to build a board? And are we happy enough with this?
Yeah, I guess it should be easy to print, right? Whenever we want to print a list of strings, it's literally just loop and print.
Yeah, I was wondering about the about whether we want to break this out to other stuff, but I think it's okay, isn't it?
Well, let's keep it then, since we went for the range from 0 to max row and max column.
Yeah.
At least when we do parse now, we can make it symmetric, so it always assumes that it starts from 0 when it parses, right? So do we want to,
good point.
because it's like in both cases there is a question of what do we mean by the beginning of coordinates, right?
Yes.
So I don't know what you have in mind. I was just thinking, just to illustrate, we want basically a reverse thing here, a parse. So I'm just going to say, oh, can I click? I'm just going to say parse board with 2 corners. And that's, we want this thing to say parse board. And that should be equal to the board. And this should be the other way around. Well,
yes.
So that's all I meant by this, is kind of symmetric thing.
Yep.
Although, to be fair, I think with this, can it see? I think in this equals, I'll jump into implementation. It has expected an actual. So that's expect. Oh yeah, no, it's all correct. Cool. So that's what I had in mind, to create a parser board like that.
I would. So can I ask that we just don't do that one? That we, because we've already got like a board constructor. I wonder whether to so we had boardOf, right? Can we say boardOf that?
Oh, okay. Do you mind also closing the tool window? I cannot click on things.
Oh, and Shift Escape doesn't work for me either. But there you go.
Thank you. Thanks. Oh, I see.
So that.
Yeah,
actually, this will be quite interesting because we're going to have confusion around the empty case of boardOf. But let's try it, shall we?
Yeah. I don't mind.
So we've got a fun. I don't know why I'm trying this. IntelliJ will. What will it do? It doesn't know that. It doesn't know what we're trying to do. It thinks we're just calling this one with the wrong arguments.
Yeah. And it infers their own types anyway, right? With type aliases, it doesn't use type aliases name, so all the types will be not what we want. Well, not all.
Board of vararg rows, which are strings, returns board.
Yeah. No, don't run the test.
No. Okay. But that's our signature, right?
Yeah.
In fact, let's do that.
Yeah, I was going to suggest that. Yes, just save button. Yeah. Save. Interesting.
So I don't know how we differentiate between those.
Yeah.
Yeah, so we've got boardOf here, which is vararg. We could do one that just had a row, first row.
Oh, I see. Clever.
And that way you could never build an empty board this way, but empty board, you could always build an empty board that way. So that would always work. That's quite sweet, isn't it?
Too clever at this point.
Just sweet. I got to go with that. So this is.
Okay. Oh wow. Okay, I would just rename it to parse board or something like that, because this is parsing, really. The other thing is gonna convert to string something. This is convert from string. Ooh. Okay. Yeah. I'm happy to give it a try and see how it goes.
So that should fix that compile problem at least, right? And then we will be calling this one. Yeah.
Hey.
I mean, I think we have just made ourselves a real, more of a problem than we needed there, but it's worth, yeah. Let's live dangerously.
So should I try and do something here?
Yeah. I think you should.
It's not the easiest thing. Should I just do the whole thing?
I think it's worth just going for.
Okay.
Or well, you can put in the implementation here and still return boardOf and then just.
Oh, true. That's a good point. So I was thinking about pushing things back together.
Yes.
This will be just rows.
Yep.
Oh, wait, maybe I'll do the other thing, which is convert to block body.
Yep.
Then I can type things here, and they're not going to hurt anyone.
Yep.
So then we have a board, and we want to return. Well, board is a set of pairs, right? Somewhere. Oh, cannot collapse this. So board is a set of pairs. So we want a set as the output. That's interesting. So we want to go through each row. And, well, we're going through each row and doing something. That's a row, right?
Yeah, that's a row. And then in each row is a string.
Yes, should we kind of row string? And, yeah, each row we want characters basically from the row chars. No, or to char array.
Strings are iterable. You can say string map.
Yeah, it does. Yeah. So we can map for each row, and it's going to be a char. Then we can say if char is quoted star, then we know it's a cell. So, well, we'll have a cell here, which is want row index. Then we want a row index.
Yeah.
And we want to map index then.
Yeah.
I'm lazy loading things I need. So that's row index to 0, which is well, map indexed again. Not so nice. So it's going to be colon index, not window.
Yeah.
I'm not sure I like this now that we have this in some parts of the code. Row means row, and here it means rows as a string. So
I know, it's a bit weird. So why don't you replace row with row as string, or just string? Just string.
I'll rename this row as string. Then this can be just row.
Yeah.
Can be just colon. I'll call it col.
That's a bit better. We're putting off the inevitable revert here, but you know.
Oh, no, I'll run it now.
I don't know what happens. That's interesting.
Just like it's an expression.
Of course, no, because you're not. Yes, you're not using it.
Yeah.
Yes.
Phew.
Phew.
So fine.
So what is the type of that thing that we are? So what's the type of that expression? The whole thing.
Yeah. Let's call it Bob.
Yeah.
It's not the type that we want for sure. See, it's units.
Because we haven't got an else.
Yes. So that was another question which I had. Can we do map index not null? I don't remember. Yeah, we can.
You can. Oh.
Yeah. Then could we do flat map indexed?
So let's just step back and
look at the type.
Yeah, first of all.
So
that is board, in fact.
Yeah, then we can do like another thing, which is flatten.
Why? So isn't that already board?
I think now it will be. Yeah, it's a list of pairs, but we just want a set of pairs, right?
Oh, right. So you just want to say, why can't you just do two set?
Yeah.
Why are you flattening it? I don't understand.
Oh, because it was too nested. So now this should type check. Yeah, it does.
Oh, okay. I missed the fact that it was listed.
Play with it if you want.
No. So we're using null to say we don't have a thing for you.
Yeah.
So we're filtering out the nulls in the map index, not null. and then that's giving us a that's giving us a 2D thing because we're doing 2-map indexed, which is why you wanted the flat map indexed. But instead of you doing a flatten and then you're doing to set.
Yeah, it's not the nicest code,
No.
I admit.
I mean,
No.
I think it's yeah. I if it works, which you still don't know.
I'm just plugging into
go on.
Then I can do return.
Yeah, got to take the other one out. 94.
And it
What?
works. Nice.
Oh, you can have 2 returns. Look at that.
Yeah, it's just this one,
yeah.
actually.
Yeah.
But I'm doing the minimal possible step.
Yeah, no, it's all good.
Yeah.
So personally, and it's just me, I think that is worse than. So the problem with this is that you're not introduced to this yet. I would say filter not null.
Yeah, it's better to have, I agree, have expressions which do one thing.
I mean, I'm even a bit iffy, to be honest with you, about the join to string thing, because I mean, I know IntelliJ tells you to do it wherever we did that, but to list of strings, wasn't it? It's in here. This join to string, I'm only just getting used to. I kind of still think of this as a map followed by a join to string, but in particular here, I feel this filter not null. You're introduced to the fact that we're going to put nulls in there, and then you get to see and then I take them out. So IntelliJ will probably complain. Or no, it doesn't. So in fact, could we? It even feels like. Can we bring that filter not null out after we've flattened?
We could bring it to any point, really.
Yeah, it just feels like it's a little bit weird. We're doing it here. I suppose we're skipping whole. We're going to end up with So what's going to happen here is we're going to end up with empty sets of things. It doesn't matter, does it? I think it's good enough. I don't like. It's a bit hairy, isn't it?
Oh God, yeah. I don't want to look at this again.
No, it's. I mean, it's a debug code, I suppose, but yeah, let's get rid of that.
Remove. I can drop that, right?
Yeah.
Also, I agree with what you were saying. I think you were saying can't remove it to there somewhere.
Yeah.
And I think we can, and I'm happy with that.
I mean, it makes it look less hairy.
Yeah.
I mean, it would look less hairy if we didn't have this at the beginning as well.
Yeah.
So can we give that a name?
Yeah.
And so we're saying all rows map indexed with the row as a string, map index column as a string. If the character is that,
yeah, sounds fine to me. Looks okay.
And then I just kind of feel I don't know.
Yeah, just IntelliJ will not let us format it.
Yeah.
How we want.
I mean, obviously we could like make it seem simpler by pulling this test out, but actually the complexity isn't here, is it? I think maybe that's better as a single line.
Yeah, there is another approach maybe, which is we're doing like 2 things. We're iterating and using indices. We could just generate all the indices into like a stream and then do the whole if outside, if you know what I mean.
Yeah.
Because all we're doing is literally like row and column, and then we can in constant time access the list of strings and to pull this character out and do our ifs, not nulls, all of that like in one place later.
Yes. Yeah. I mean, the other thing, of course, we can do is just set up a mutable set and add things to it.
Yeah.
which doesn't feel bad by the time we get here. Let's push on. And
yeah,
I think this is not bad. I don't like the way it's formatted. I wonder whether.
I agree.
Yeah, you see, that's really annoying. The fact that I can't do that.
Mm-hmm. Oh, that will be better.
That. All rows, map indexed, flattened.
Can I inline this then? Oh. Can we inline all rows, maybe?
Yeah, I suppose so. I mean, I kind of want to give it a name, but
I cannot use the. Oh, sorry.
That's weird.
Cannot use your shortcuts. Can we inline? Oops. Please. Yeah, I think that's better.
Yeah.
Okay. Can I run?
Yeah.
Oh.
So it was a flatten, not null.
Flatten, not null to set. That's what you want.
Yeah.
Flatten to set.
Okay. So now it feels to me like we should be able to say something like board with one corner, board with two corners, empty board. Well, so this is parse board with two corners. Yeah, okay. I've got to the stage where I really want to start sort of breaking these out into separate sets of tests because they're all doing different things. But I think maybe, given we're working on one screen, that's going to be a bit nastier than I can deal with. So what is it? Command minus.
Mm-hmm. Oh, yeah. We can do Command Shift minus. It closes everything.
Okay, that would be quite interesting to look at what we have then. So we have some tests. We have a board of. So we have.
Oh, you move in just one thing, I think.
Yeah, I think that's what I'm trying to do, but I'm doing it very, very badly.
No, I think you move in just one line.
Yeah, no, that's what I wanted. Oh,
okay.
No. Yeah. Right, is that okay? Right. Command Shift minus. So you're saying that I want to take this thing and like that, maybe.
Yeah, well.
Okay, so we've got two ways of building a board. One is from some live cells, and one is from some. This thing is not private, and actually feels like some output. So our public interface is.
Mm-hmm.
What does a cell look like? What does a board look like? Build a board, render a board, basically, and step a board on. Save that.
Yep. Yeah, I knew you would notice that.
Right. It feels to me like we should look at a glider or something just to check.
Yeah, sounds good.
In fact, do we have any tests for step at the moment? Yes, because we did a single step here, didn't we?
Yeah. Let's do it right. I can tell you what to type.
Okay.
From other source.
So I'm going to go. Let's take a copy of this thing. So glider. We had a blinker. Blinker was easy, and I knew how to do. Right. Let's do that first.
Okay.
Just as a little warm up.
Yeah.
So this is board of, and now we can type it out, right?
Yeah.
It's going to be, if we start with star. This is quite interesting. If we start with star, it's going to blink, but we're going to gain something at 0 we're not going to see.
Yeah, it's going to blink not the way we want it to blink.
Yes. So let's
So I do vertical then, maybe.
let's do that.
Oh.
That gives it space
Oh,
to.
I see. See what you mean. Interesting.
Interestingly, we haven't asked the question: what happens if we parse the board with dots at the bottom? And I guess the answer is that's okay, but I'm not going to try and find out now. Okay, so what we expect. This is board.step. And we expect a board of dot star. In fact, 3 of those.
Yeah.
Fat today. That.
Oh, one more like that.
Yes. What did I have?
Yeah.
Feeling lucky?
Oh. Okay.
Or do we want to save this test by not running it and save it? I think let's play the game properly. Let's say
yes. Let's see what happens. Whoa.
Awesome.
Well, it's quite interesting that you didn't want to do this, but I would write these things like that.
Yes.
Just to illustrate what I mean.
Yep.
There's something there. No, not really. Okay. And I would also add dots to make things symmetric.
Yep.
And we're missing one more step, which is that when we do 2 steps, it goes back to the original one, right?
Yep.
We do. I don't know how you would express that.
Okay, so I have a plan on that. And
I'll just check that it works first. Maybe also this formatting is kind of nicer. What do you think?
Yes, I do prefer the extra bracket. It's a problem with scrolling up and down with a small screen and lots of.
Oh, I see.
3 people on YouTube ever watching this. That's good. So my theory, for what it's worth, is that what I'd like to see is I'd like to be able to get a sequence from the board, right? So I'd like to get a sequence of boards that I could just take 1, take 2, take 3.
Yeah.
And then instead of saying board step and then board step step, what I'd really be able to like to say is, so I've got that, and then I'd be like to say val sequence equals board dot to well, maybe just sequence. I don't think it's 2 sequence, it's a sequence, right?
Yeah.
And then this is board, this is sequence take 1.
Right.
And then this is sequence take 1 again. I never know.
Yeah. Well, it's an iterator basically, right? Because it is.
Something like that.
Yeah, sounds good.
So we can force that into some sort of sense of something.
Yeah, just like, where is the type? Type ls.
So this is sequence of board. Escape going to work, enter going to work, something's going to work. There we go. And this is board.sequence. Okay. And then this is going to be our public interface again. How is your sequencey stuff?
Oh, I would do it. Oh, sorry. I would do it like this, like sequence.
Yeah.
The function built-ins. This, basically, and then yield forever. We want to yield something. That's going to be this step. But we want to update the board, so we'll have next board, which is this.
Yep.
So we want to do something about it.
So
Maybe
you want to
we
yield. You want to yield next board, and then you want to say this.step.
Yeah.
Next board.step.
next board. Oh, it's their own this.
This, yeah.
To do this as
Sequence.
and then we need a while true, I suppose.
Yes.
Is that happy? Oh. This must be outside.
Yeah.
And it needs to be updated. That's a crucial bit. Wow, that was more complex. I thought it was going to be much easier.
So I have a cunning plan. I want to see whether this works. But
Okay,
yeah.
you run. I cannot destroy this now.
So if this goes wrong, the place I expect it to go wrong is actually that sequence take, because things like take on non-sequences work differently, and I get confused.
Oh,
like if you take one from an array.
Sorry to say, it won't work because we were yielding board before taking a step. Right? We yielded it. We should have modified first, then yielded. Right? Because our take doesn't return the original board. Our sequence doesn't include the original board. Maybe it should, actually.
Okay.
You know what I mean?
I think I know what you mean. Let's not update this, and let's type that again for now, right? So we had fun board.sequence equals, and then and this wants to return a sequence of board. So you went sequence var, allowing ourselves to feel the hate for a minute. Var next equals this at sequence, basically. Yeah. Then while true, yield next.
Yes, but we need to update next first. That was the problem.
Yeah, update next first.
So we need to do above yield next equals next.step.
Why? Surely we need. Surely the first item. The first item should be the first item in sequence. Oh, should the first item in sequence? So that's the question. Should the first item in sequence be this board, or should it be the next board?
Yeah, and this is why it didn't work in the test, because we expected it to be like the next board already. Right?
Yes. So I don't know. I kind of feel that I want the first item in the sequence to be the board that I put in seeded the sequence with.
Yeah, I agree.
So in other words, we should have the same code. We just should test it differently.
Probably, yeah.
So this is next equals next. So
let's just run this and say
yeah. Okay, and so going back to our blinker, so these is my boards, boardOf.sequence, right?
Yeah.
And then this is, so in fact, the first one, let's take that and put it in here. So we're saying that board.take one.
I also wonder if take returns us a list or a single board. So it returns us a sequence, which will not be equal to a single board, right?
Why does it return us a sequence?
Because it doesn't know.
Because we've already.
It doesn't know how many it would take.
Okay. I've got a theory.
Yeah. Ooh, interesting.
Oh, hold on. We can't do toList. We're going to have to say take some.
We can take toList. Oh, I see.
So if we say take one toList, and I obviously haven't internalized sequences very well, but I think that this should be boards, right?
Yes, I think that's correct.
So we're saying this is just one item. That's the one item because we haven't stepped it on. Let's just, I'm just going to cut those for now, right?
Yeah.
As a sort of low impact way of, oh. And when I say cut for now, I'm also going to delete that. Oh, hold on, what have I done? I'm being an idiot. Sorry. Right, that. Right. We're saying if we have a sequence of one thing, it's that thing, right?
Yeah, the same thing we had.
Yeah. I mean, this is an odd way to test it, but okay. And then, so I know I've got it sitting in my paste buffer, so I'm just going to paste it into here.
Should we just take two now? What do we need?
Yeah, I'm going to take that.
All right.
I say take, I mean, like.
Yeah, makes sense. Yeah.
So
we're
that's
now going
there. Just lost one of those.
Yeah, that looks right, except that take two on line 91, don't run tests.
That one.
Yeah.
Okay. And then, so what we really wanted to show was one more.
It's not too bad overall.
No, I mean it's a bit like weighty, right?
Take three. You didn't type 3.
Oh.
That would be tragic.
Okay, so I mean I don't like the test much. It's okay, but the sequence is a good abstraction, right?
Yeah.
This, however, is tragic. But there's another thing, and it is build sequence or generate sequence.
That's going to be better, yeah. And then you have argument as seed, right? Something like that.
This.
It's step. Yeah, that's much better. Oh.
I have to go and look that up every time because I always think of the coroutines one because that seems very natural, except that you do need the while loop and all that horrible stuff in it, whereas that's just a thing, right?
Yeah, no, that's definitely better. Now I even question if it's worth having a function on the board because this is too obvious.
Let's move it as part of our API down into so board.toListOfStrings. So ultimately, board.step is subsidiary now, right? I mean, this is what we really expect is to be able to build a board, to be able to see it, and to be able to get a sequence out of it. And I guess actually, if we take the sequence, right, we map it. I'm not suggesting we do, but and we can actually test this as lists of the things that we want out. So this would be like our rendering code would basically be saying take the sequence, map it to list of strings, and throw it out on the screen.
Yeah.
Okay.
Uh-oh.
Well, I'm glad that was reverted because I was obviously an idiot.
I'm not sure what went wrong.
Because our rendering code
it doesn't render dots. Yes.
It doesn't
yes.
render the empty ones. Okay,
Yeah.
let's well, we learned something. So a glider should make a thing that basically just gets bigger and bigger, and then shall we write a glider?
Yeah.
And I'm interested in the performance of this thing now, right? Because and now we've got a sequence, we can basically just take however many we like out of it, like 10,000 or whatever, to get 10,000 iterations and just see how long the test takes to run.
Yeah, sounds good.
I mean, no proper benchmarking, but the length that a test takes to run will be a good some sort of good.
Well, it's better than not benchmarking.
Yes. So how about making a glider and then watching it?
Yeah.
So it's complaining about.
Do you mind if I do this? Because this was blinker sequence. Sequence. This was glider performance. That's like different things that we're trying to do.
Good with that.
And glider. Well, should I commit this? Do we want any assertions for glider?
I think, I mean, if I had an approval access library here, I might say let's spit that out as strings or something we can see, but I'm happy to just print them for now and take a look at them.
Just for now, so this works. And we want a glider here. I'll copy it somewhere else, so it's this with a star, then something like that. And then it's just star. I think that's all. And what are we going to do? 10 to list until
yeah, I would say 10, take 10 for each print run.
Sorry, 10 for each.
Yeah. Well, if you
right.
Yeah. If you say map at that point, whatever. Board.
Sorry, you mean map before for each?
Yes. I mean, it feels like what I want is my list of things that I'm going to be printing.
Yes. So it's to what we called it? To list of strings.
List of strings, join to string.
And then it's going to be println it.
Yeah. You probably want to join this to string, but it's not going to fail. So let's just see what we get out. So you can use the mouse there.
Oh, interesting. Yeah. Oh God, of course I should have joined. Yeah, thank you.
So let's have a look, because that's oh yeah, it's no real help in visualization, is it? So this is map dot join to string. Join to string. These are the lines, so I want to join them with 10. Like that. Actually, we just run this one now.
Yeah. I
agree. And shall we put in a blank line?
Yeah. Well, yeah, I think it's going to be more readable. Oh, interesting. Looks okay. It like moves bottom
Yeah.
right to the bottom right corner.
Yeah, and so it keeps on making everything bigger, which is what we kind of expected, right?
Yeah.
Excellent. Okay. So just
Yeah.
now when we're playing with
we need a terminal operation, otherwise it's going to be too fast. It's not doing anything.
True. Pick a terminal operation. Actually, if you just do for each.
I think so. Yeah, that's probably the best. Okay.
Still very quick.
Annoyingly. So it's also interesting which way we want to scale this thing, because we don't the set of cells that we have is not that big. We're increasing the amount of iterations. But what if the set of cells is bigger, right? This stays like pretty much constant set of cells.
I agree. So
maybe we can have more gliders.
So there are the things that generate gliders, right? And there are other things that generate things. Let's look up Wikipedia.
I actually thought about something simpler, like generating our board in a different way. I mean, just adding more things to it somehow. Yeah.
Can I just show you what I mean?
Oh yeah, please. Yeah.
I've lost my.
I know there are some.
I just wonder whether some of these things that make a board that gets bigger and bigger and bigger and leave things behind would be a good bet.
Maybe.
I'm going to have to stop IntelliJ doing this thing, I think. Has that stopped IntelliJ doing this thing? Kind of seems to have done. Is this going to work? Oh, it's gone full screen again. That. Okay. Game of life on Wikipedia. Almost game of life. There we go.
Yeah.
So I wonder whether something like this would give us more and more pixels to deal with.
This is quite complex to get right.
Okay, but because I was looking this up last night, this thing is surprisingly easy.
Okay.
And that thing basically just makes a universe that gets bigger and bigger and bigger, but leaves things behind.
Oh, sounds cool, man. I'm happy to try that.
So we've seen the glider works. I might leave that behind as a artifact, but should we try this thing? So that's *** dot bang, then a thing like that, then .. then *****.
Actually, empty space will also work for us, right? We didn't have to have dots. We never. You just typed space instead of.
Oh, I did.
Dot.
Yes. Yeah. Yeah.
Maybe dot for consistency.
Right.
Okay.
Does that look like that thing?
Yeah, it looks okay to me. I was watching you. So.
Okay, so let's take a few iterations of this.
Okay.
Then, I'll run it anyway.
So I hope it doesn't disappear. Oh.
So you see it's left stuff behind, and then
That's right.
it just gets bigger and bigger and bigger. And it feels to me, I mean, so obviously anything we do in performance is going to depend on how sparse the actual world ends up. But it feels like these are sort of game of lifey size things.
Yeah,
I don't understand why this has a blank line in it.
Oh, maybe there is a minus. We're looking for max off, and then we cut off everything which goes, into the negative numbers.
Okay.
So our print printing only kind of positive rows and columns. So maybe that's why. That's my theory. Yeah, no, I'm convinced. Oh,
it's getting smaller again.
What? But I mean, from performance point of view, I guess it's.
We have a bug there, don't we? There's something odd going on there.
Hard to know. This is really hard to debug.
Yeah, isn't it? It's almost like we don't have enough tests at this point. So I wouldn't expect that our board should be able to do these outside rows, because we've seen that doesn't happen.
No, these can be negatives, right? If they go above into minus rows.
Right.
Then our max of column will find max column, but we will not show those because their rows are negative, and we're only showing positive rows.
Ouch. Do you want to...
So positive column, but negative row. That's my theory. But I think either way, if we just want to try some performance improvements, we can go with this, see how long it takes, make it faster, and even if it's not entirely correct.
Okay, I think we may have to do another one of these on fixing our rendering code, but yeah.
It might not be wrong, I think. So, oops. So should we try something like what you had before?
Yeah.
What was it? 100,000, 10,000?
Yeah, try that.
But I'm impressed it's not glider anymore. It's like, oh, that was too fast.
You still got to do the for each somewhere.
It's also not a glider anymore. Whatever this thing called. Something performance. Renamed.
As none of the other tests take any time, let's run all the tests, because we're messing around with the
yeah.
This one will take almost
10 seconds. Oh, that's all right. Yeah,
that's about the right sort of time. So let's just go and run everything.
Yeah. Also, to be fair, if I were even doing this, I would watch my CPU, maybe run it a couple of times to see distribution of 3 runs.
Yeah, absolutely, and then get whatever it is, JMH, Java micro benchmark harness thing running. It's
also you are the expert here, right? You did this talk at Kotlin. It's about Kotlin performance.
Yeah, that's why I don't want to go and bring out. So that was awful, because I ended up running things on a Raspberry Pi in order to have an environment that wasn't skewed by anything else running on it, and trying to get consistent test runs was horrible. I've still got that Raspberry Pi sitting down here somewhere in a little box. So we are let's go with what we've got. Where do we have? So we're live neighbours feels expensive.
Yes, and there is a step. I think that's what we're really testing.
Yes.
Maybe the just scroll down. It was that's the step. I also was thinking about refactoring it a little bit, maybe.
Mm-hmm.
I can click now. Nice. Because it's a bit confusing what we wrote yesterday, I think.
Yes.
These
can I try
cells.
one thing before you do?
Oh, yeah, please.
And it's because I had a little play last night. What I wanted to do was I wanted to cache neighbours.
Yeah, makes sense.
And it was a sort of gut feel. And so I went, if I want to cache neighbours, I'm going to cache. I can't cache them in a pair, right? Doesn't work for me. Just run this one more time so we remember the numbers. And it was around 10 seconds,
right? Last time.
11
first time.
Yeah.
So, yeah.
Something performance, something like that.
Yeah.
Right. 10.5. Right. Let's pin that one. Okay. On a whim last night, I said, let's define a class for our cell.
Oh, so you dropped your own constraint.
Yes, absolutely. Well, no, but yes, because I think, yeah.
Okay.
Yep, absolutely. So val, so this is in a pair. It's first,
yeah.
int. Second.
So we basically writing our own pair.
We're writing our own pair.
Of val second.
Okay. And that's saying I've already got one of those, right? And then all of our places at the moment won't work. But if we define our own infix fun int.to other int equals cell this other. Okay.
Right.
So now I think all of these things will be using our thing. Every cell will be our cell, right?
Can I rename this to that? I kind of like this thing. It's this and that.
You can, and indeed you have. Okay, so that was like,
yeah.
If my playing around last night is anything to go by, that's a dramatic difference.
Why is it faster now?
Absolutely.
Is that what you noticed last? Wow. So your custom pair is better.
So I'm betting, for what it's worth, that if this was T.
Right.
T. I haven't read this because it got late last night.
Right.
So this is cell of T, isn't
T,
it? Yeah. And this is set of cell of int, which is it's going to be really annoying, isn't it? How often do we say cell? Let's see how often we say cell. Woo. Cell. It surprises me you got a problem there. These ones. Tell you what, let's type alias it. Yeah, let's go back to type alias. So we'll say this is. Let's go back all the way to. Yeah. Right.
Yeah.
Let's leave that alone. Call this my cell.
Yeah.
T. First is a T. Second is a T. This is my cell. That's going to be cell because we're going to say type alias cell equals my cell.
Yeah, sounds good.
Okay.
Yeah. Approved.
I approve this message.
And you expect it to get slower now because some code.
I expect we're back to generics and therefore back to 10 seconds.
Oh, interesting. Yeah, looks like you, right? And if you just hide the generics now, it's going to be back to normal. Yeah.
Yeah.
Interesting.
So if you want performance, in this case, I mean, that was what? Taking it at face value that the rest of the tests don't take any time. We shaved 30% off.
Yeah, no, that's an impressive improvement. It's definitely not like, this ON notation doesn't include generics. You will never get to this with ON notation.
So it's 8 seconds. So yeah, 20%.
It's still pretty good.
I mean, cell is our fundamental thing, right? We're doing a lot to it, but interesting that, just that one change. I'm getting hungry, but so I'm interested. Are there any more wins? So where do we expect wins? We don't expect wins here. Everything is in. Why is that not going away?
Oops, sorry, I'll stop moving.
So board.of, I'm not interested in. I'm just trying to do my command minus. There we are. To-list-of-strings, we're not doing that at all anyway. So board.step is our baby, right?
Yeah. I think we just that's what I was going to try. These were survived cells. Survived cells. When we filter our live cells, essentially. Then we have survived cells, and these were newborn cells.
Mm-hmm.
But that makes a bit more sense to me.
Run it so that it,
Yeah, and then we are basically going through. Oh well, we'll see it. We are calling live neighbors for all live cells, and then we're going through all the neighbors of live cells. And because live cells kind of clustered, we will call live neighbors on them again. If you know what I mean.
So you're saying that so the flat map that we're flat mapping over is live cells, in fact, here.
Yes, it's also quite complicated. We could have done something like that, probably. We flat map and get all the neighbors of all live cells, which are dead, if that makes sense. And then we filter dead cells so to keep only the ones that we bring to life. So this way,
you're gonna want to leave those alone so we know how quick it is.
What? Sorry.
Well, you just lost that test screen, so we don't know where. So.
I know it's like after it pops up, right? At the bottom.
Yeah, but I don't want to. It's not only whether it passes or fails; it's whether it how long it takes. Right. So interesting. So that's 8 seconds. No, but that's 8 seconds, which is roughly what it was taking before with our change, right? So
yeah,
with it was 10.5 seconds, give or take, with pair. It was 8 seconds, give or take, with before with this change. Let's say with our own cell type. So yeah, I don't think it's made it any quicker yet.
No. It was just refactoring, really. I think neighbors might help because we will be calling neighbors again and again, caching neighbors for a cell. Now we have a class. Do you mind if I try that?
Please do.
Okay, so say we will have a neighbors thing.
So we've got neighbors. Yeah, let's go and make it.
What is this? A list of cell.
Well, we've got an extension method at the moment, so let's just paste it in.
We have what?
We've got an extension method for it down the bottom.
Right. Yeah.
One. So let's just take that and put it in there, or call it, I guess. Ooh.
Yeah. Well, we're going to do maybe a lazy thing. Then it will be initialized once, if that's what you meant.
Yeah, I'm interested to see that.
No, it's not happy. Oh, bye.
I have to look it up every time. So is that just check that's actually calling? So that's a val, whereas that's the function. Okay.
Yeah. So that's kind of the whole idea.
But
so now we don't want to call neighbours up anywhere except.
Well, tell you what, I have another, just because I'm going to get confused here, right?
Do you mind if I do that? So we were calling neighbours, now we calling this.
Yep.
So if I just run this, that
Yep.
might go faster. We'll see if that helps. Maybe not. Maybe slower. I think it doesn't finish now. Interesting.
Significantly slower. I mean, run it again, just.
Yeah,
you know.
yeah. Oh, yeah, that's really interesting, didn't it?
I'm going to run it again, if you're not. But yeah, so that was 15.
Yeah.
Now, I don't know what this tells us. I don't, because my gut feel says we are reusing cells between boards.
Yeah, it is slow.
Right? Because we are. So survive cells, we're basically taking the cells from one board.
Yeah.
And we're moving them onto the next board here, right?
Yeah.
So you would think that caching, basically, the list of neighbors for every cell. On the other hand, maybe it's the nature of that pattern that it's not that it's moving across. There aren't many cells that basically survive from one generation to another.
Yeah, and just where there's a bunch of code and lazy, which slows things down, right?
Yes.
Lazy targets.
Yeah. So.
Yeah,
so yeah, I mean, I kind of expect that this was what I expected to work, right? I expected that once we once we were able to carry state in our cells, I expected that a little bit of caching would work wonders, basically. And it turns out it doesn't. And I think it doesn't because, as I think about it, we are reusing very, very few cells. Because generally speaking, these patterns are ones where things move across the board or whatever. If we had a board that was static, this would make it a lot quicker. But and maybe, some of those, like, really, when they do Game of Life in Game of Life, where a lot of the board is static things that are then, logic gates or whatever, then this would speed it up quite a bit because there would be much of the board that was static and then some of the board that was moving. But the fact that this actually slows it down in our case, I think is really interesting.
Yeah. I also think there are lots of things that we're doing which will copy things along, like all this filter. We should have really done it, because filter, if I click into it, it will create a new array list, basically.
Yes.
On each filter, and instead we could have used something like count. That might help. Would be my other guess. So instead of count here, we just make the whole thing return count. But that should be renamed.
I see. Yeah, I like that.
Count. And if we look at count, this count should be much better because it doesn't create a collection. It just really increments a counter.
Yes.
And runs
Yes.
So things like that help. Also dead neighbors, I suppose.
Well, let's fix that one. Let's run it. See, because I'm.
Oh yeah, I didn't notice this one. So let's just do this. Maybe this can help. Well, I should have rolled back this change with neighbors.
Yes. Yeah. Should we kill it and do that?
Yeah, I'm stopping it. So now going back to this thing. Now we can see that the neighbors are not used anywhere. I'll comment this out and I'll run it now. So we should be at least better than 8 if this helps, this counting thing.
Well, you haven't put that back yet. So so this is still doing live neighbors dead cell count there. This should be 8.
Oh, okay.
Oh, 10?
Okay. Weird.
Okay. We may TCR is not good for these.
Yeah. I don't know what's happening anymore. Did we fail a test somewhere? Why everything was reverted?
I don't know.
Not
Yeah, my
maybe this change was wrong in some way. So, well, maybe it was.
So that seems to be slightly quicker than our again on a sample of 1.
Yeah.
Slightly quicker than our previous one. I mean,
I'll try
oh yes, gut feel.
And then fix all the errors over there. Oh, we cannot do that easily. This count is not going to work. Oh well. We could have just called neighbours, I suppose. Cell neighbours. Can we?
So
sure.
we are assuming those are dead.
Yeah, because if we bring it to life, there is no harm. That's kind of changing semantics a bit. We're looking for all neighbors.
Yep.
Then we're not even using dead neighbors anymore. Well, I'll just give it a go, see if it's a difference.
It got to that stage where, yeah, my lack of blood sugar and the fact that you've been driving for a while means that I've given up.
Okay, yeah. Back to 8 seconds, or maybe it's just fluctuation.
Okay.
Oh well, it's definitely lunchtime.
It is lunchtime. So so what have we done? We have the only major performance thing we gained was not using generics in pair, basically. Right? Defining our Excel class. I'm with you. I think there are gains to be had, but surprisingly few at this point. But I think in order to know, we'd have to. I think any gains that we get now are going to be around. We're going to have to ask for what sort of board do we want to gain. I mean, we've already seen that we gain empty board, but do we want to show? Do we want to be quick for boards that are quite static, or do we want to be quick for boards that are quite dynamic, or what?
My feeling is that, yeah, absolutely, I agree with what you're saying. I think somewhere here there must be a way to improve this, because it's doing quite a few things, like all these filters, flat maps, all of that.
Also, we are for every cell. I mean, I think if we were to collect all of the dead neighbors of every cell and put them in a set, and then only go through that set, it would be, because at the moment we are going to every cell's dead neighbors, which means that every dead neighbor if is a neighbor to 2 cells, we're doing the calculation twice.
Yeah.
And then we're putting that into the set here, or in fact the list, and then so this survived cells plus newborn cells. This I predict. Newborn cells, lost my mouse here. This I predict is going to be a lot bigger than the actual number of newborn cells. So this addition, I think, is going to be, adding 30 things, but only ending up with 10 more things in the list in this set. Probably, I don't know. I mean, this is just my sort of gut feeling on it. But it is interesting how little things that you think are going to make a change seem to.
Yeah, it's very unintuitive, really.
Yeah.
Sometimes.
The JVM is really hard to predict. Often.
Yeah, I'm also looking at the maybe what inner loops to improve. This is an interesting thing. If we just rewrote this, maybe instead of equals 2 or 3, that could speed things up. I'll just try it. It's because it's so easy. Right. No lunch. Equals 3. Because this looks like an optimization to have. Oh well. Takes too long already.
Yeah, it's not helped, has it, really?
Not really, no.
Again, I mean, it may well depend on the board as to how often that is actually ever hit, right?
Yeah.
So I think, yeah. I'm not sure debugging on YouTube is a good idea, but I think I certainly need to understand why we are not displaying all the board I think we should be displaying. Because I also wonder whether we have the board that we think we do at this point. But I'll maybe spend a bit of time tonight playing with that, and then we can come back soon and have another little play at performance.
Okay, so I'll turn off your screen then.
Yeah.
Yeah.
We need to revert to somewhere that's not ad hoc, don't we?
Ad hoc in what sense?
Ad hoc, well, just like what happened at the moment. We've got an empty dead neighbours. We've got
right.
Yeah. I mean, yeah. This is the point where TCR hasn't helped us because we've been committing changes that are just sort of random walks around, making things quicker.
Yeah, true. We should have disabled it probably for performance experiments.
I mean, I always like hacking on performance, but I'm always humbled by how infrequently I seem to make any difference. And also just like the fact that one change to sell was the thing that made the biggest difference, and just I didn't expect that at all.
Yeah,
I mean, well, I did it last night, but only on a whim, just to try it out. Like, oh, brilliant! Wow. Right, well, let's hope this has put Dave Denton to sleep.
Good.
It was fun. I look forward to seeing your next hat.
Yeah, it was fun. Let's maybe do something sometime later.
Have a good lunchtime. Time for bargain hunt for me. It really is. I'm missing bargain hunt. Look at that.
Oh, okay. Bye.
See you, Dimitri.
See you.